Hi guys, this is the last video for this unit and it's all about an augmented matrix. Really on the test, if I ask you to write an augmented matrix, I just want you to write it. But if I say solve, then I want you to use your calculator and find the answer for your x and your y. This is used when you have systems of equations. So instead of breaking the coefficients and the constants into two different matrices like we did in the last video, we're actually going to put everything in one matrix, and it's called the augmented matrix. Okay, so it contains both the coefficients and the constants, and basically you just draw it like this. Got your matrix bracket, and you go and write down the coefficients for the x's in this column, in the first column, and the coefficients for the y's in the second column. And then you draw a dashed line. Those are all our coefficients, and then on the other side of the dashed line you draw the constants. Now on your calculator you will not see the dashed line, so you just have to imagine it there. Okay? This, if I say write the augmented matrix, this is all I want. If I don't ask you to do anything more than write it, just show me what it would look like. Okay, now in the calculator, if we wanted to solve this, so here's the system we're trying to solve and figure out, x and y. So I just, instead of doing matrix A is this and matrix B is this one, do the inverse of A times B, instead of doing that, I just type this one in just like it looks. So it's a 2 by 3. And so in my calculator, I go to the matrix, edit A, and I'm going to do a 2 by 3. Okay, put in my information, 1, 1, 4, 2, 3, 9. Okay, and quit the screen. Now I go back to the matrix, and I go over to math. In order to solve this, we need to do reduced row echelon form. That's how you solve it. So we go RREF. RREF. This is letter B on my calculator, RREF. And then I need to take that RREF of matrix A. Now, what's going to happen, I'm going to write this down, but if you'll notice, this in the front, the square matrix in the front, that's your identity matrix. In the back, the 3 and the 1, that's your solution. That's your x and y value. So we copy it down, 1, 0, 0, 1, and then 3, 1. So if you wanted to write down x equals 3, y equals 1, that would be your solution. Now, you can also do this with a system that has 3 variables. So for the system with 3 variables, let's say we have this system given. Negative 2x plus y plus 5z equals negative 20. Negative 5x plus y plus 6z equals negative 23. And negative 5x plus 5y minus 5z equals negative 10. Now, when we first started this unit, you guys had to solve this by hand, and so now you can use your calculator to put the matrix in there and solve it using reduced row echelon form. So what you'll do is you'll make your augmented matrix. So all of your x's in the first column, all of your y, the coefficients in your second column, and the z's in the third column. And then your constants in the very last one. Again, remember that you will not see the dashed line on your calculator. If we put this into our calculator, we will put in a 1, 2, 3 row by 4 column matrix. So if we go to matrix, edit, I need to do a 3 by 4. negative 2, 1, 5, negative 20, negative 5, 1, 6, negative 23, negative 5, 5, negative 5, negative 10, and quit. Now if I do reduce row echelon form, for matrix A, notice here, if I cover up the very last column, I have the identity matrix. This is the answer to X, Y, and Z. So the X is 0, Y is negative 5, and Z is negative 3. Didn't have to solve it all by hand. Now if you have special solutions, infinitely many or no solutions, then let's set up the identity here, or I'm sorry, the augmented matrix. Go put it in your calculator. This is a 2 by 3, 2 by 3, 9, negative 3, 9, oh, negative 9, go back up, negative 9, 18, negative 6, negative 30. Run reduced row echelon form on it, matrix over to math. Reduce row echelon form, go get matrix A. Alright, now if we look at what happened, I don't like seeing all of those decimals. I could go in and tell my calculator to convert all of those decimals, the decimal to fraction by hitting math. Change it to a fraction number 1. Enter. Alright, now I can see it all on my screen. And so if you take a look here, for your solution, we have the identity matrix. No, we don't even have the identity matrix. Notice I've got 0, 0, 1. This bottom row here, the bottom row is like you canceled out all of your x's, because remember all of the x's were in this column, and you canceled out all of your y's. So this kind of says, hey, I don't have any more x's, I don't have any more y's, but I did end up with a solution for your constants. So this would be like 0 equals 1, which we said, no, that's not true. So in this case, if you see something like that, 0, 0, and a number, then it's no solution. Okay, let's look at the last one. Again, I'm going to go into my matrix and I will edit it. Negative 1, 2, 2, negative 4, negative 3, 6. Edit it. It's still a 2, 3. Negative 1, 2, negative 3, 2, negative 4, 6. Go into the matrix reduce row echelon form for matrix A. And notice across the bottom row now we have, if this was the column for x's, we have all the x's that canceled out, all of the y's canceled out, and all of our constants canceled out. So we have 0 equals 0. So 1, negative 2, 3, 0, 0, 0, and this side is 0 equals this side is 0, and so this is true, so infinitely many solutions. We'll do some practice problems in class. If you have any questions, let me know. Goodbye.